Hello everyone, in this video we're going to be demonstrating the difference between default and parameterized constructors. And we're also going to be calling the superclass constructor within our parameterized ones. So let's start off by looking at what we've got here. I've actually got three Java files. Now the first one is the one that's got the main method. This is where we'll be launching our application. And we've also got a parent class that pretty much doesn't have anything in it yet, just two instance variables, the string and an integer value. And then we've also got the child class that extends from the parent class and it's got one field of the float data type. Now I've really kept this sort of like very generic names and all that just for demonstration purposes. You would use the concept for your own program using meaningful names and something that fits for your application. So let's go ahead and start with the parent class. Now I've just put comments here that you might hear the word parent, sometimes known as the base case, sometimes known as the superclass, pretty much mean the same thing. And for the child class, it's pretty much the same as well. So we've got the child class, also known as derived or subclass. So you could just hear them with different ways, but you know, pretty much they mean the same thing. Okay, so let's go ahead and create the default constructor. Now the default constructor doesn't take any parameters and it's pretty much the same name as the class name, followed by just a parenthesis, open and close parenthesis. In the meantime, I won't really do much. What you want to do in the default constructor is probably up to you, but most of the time you want to maybe give default values for the fields that you've got. So for the string, I'm just gonna just say test when I learn how to spell it correctly. And for the a value, I'm just gonna give that a value of 0. These are just the default values. Yeah, just for testing purposes. Now, when we want to create the parameterized constructor, now that's from the name. This constructor is also got the same name as the class, but it takes parameters. And notice that Eclipse is complaining because we can't have the same names. But as soon as I start filling in information, it's happy with that. So this is our first parameter. So that makes it a parameterized constructor. But I'm going to add one more parameter and it's going to be int value as well. Now notice that I'm using the same names. These are the local variables now. These variables, a string and a value, are local within this block, right? So now every time we want to refer to our instance variables, here we need to refer to them as this keyword so that the compiler can distinguish who we mean. Right? I don't know if that sentence exists, but I hope you get the point. So we'll need to do the same here. Notice that in this particular block, we didn't really have to use this keyword like we did for this one, but that's because the compiler knows who we're referring to. As soon as I click on this, it highlights that one, right? Because there is no local variable within the scope of the same name as the a string, so it's fine with it. You might want to get in the habit of doing this anyway. That's also recommended. Okay, so this is our parameterized constructor, and now we want to override the toString method. I'm going to use the override keyword just so that it helps us make sure that we haven't made a mistake with the way we are with the method name. So if I say toString, like I'd make a mistake, now Eclipse is going to complain because we need to override the same name as it is. So it's a small t for the toString. Now because this method returns a string, we need to make sure that we do return a string, otherwise the compiler is going to keep complaining. Now what we want to do is we just want to print a string representation of any object that's created of this class. So what we want to do is whatever, like in this particular case, I want it to print the fields, all of the fields. So just keep some spacing between them. And this dot a value, I could have omitted this, but I think it's good to show you. It's good to use it and also to show you a variety of Okay, so I can still go without using this keyword, but let's keep it as a good practice. Okay, so this class is complete. Let's just save it, and we can always give this a test. So what we can do is we can create a variable of this type, the parent class, and we can just call this parent. And if I want to call the default constructor, it's pretty much the constructor that doesn't take any parameters. So this is our default constructor. Now nothing's really going to happen here because we've just created the object. Now if we want to create another object, but this time using the parameterized constructor, what we are saying is that create an object but give it the following values. I can pass whatever values I want from the other class and then have these be assigned to the instance variables of that object, or the variables of that instance. And so in the first time, we've actually just kind of didn't give the user the option to make any or choose any data for the object, but rather just giving it the defaults. So let's go ahead and just create. I'm just going to copy this line and I'll show you what I need to change. Now first, I actually need to change the object, because otherwise we can't declare the same object twice. But this time I'm actually going to pass some values. So I'm just going to might as well say test2 just to be a little bit different. And the integer that I'm passing is number 2. And I'm need to make sure that I'm passing a string and an integer. Now if I run it, also nothing's going to happen, but the objects are created in memory, but we haven't done anything with them. So let's go ahead and print a string representation of each object created, and that's going to be done through the toString method that we've overridden in the parent class. So because we've overridden these two toString methods, we can simply print out the object just like this. Okay, so let's just do the same one again for the other one and run it. So the first object that was created through the default constructor have given us the default values, which were test and 0, whereas the second one has actually taken the values from the user or from the main program and then created an object with the following states. Okay, so we can do the same thing. Now for the second part of the video, I want to talk about how we can call the superclass constructor from the child. Now to create the default constructor, I want you to think about this before I type in anything, because we've already explained how we create a default constructor in this parent class. So give it a thought before I start typing it in, but I hope you figured that it's going to be a public and same name as the class itself, and just some empty parentheses here. And what I want to do is just want to give the float a value of 0.0. That's it. Now the constructors are not inherited by child classes, but they will be, the default constructors will be automatically called. Okay, so I'll show you in another video what I mean by that, but for now let's just focus on getting the parameterized constructor, which I'm gonna do just like so, but this time I'm gonna be passing all the details that we want as we would for the parent, but the child class also has a new field, which is the float value. And then instead of just reassigning these to what comes in from the user, we can just call the superclass constructor explicitly and pass the values a string and the a value. So that way we've explicitly called this superclass constructor, and we want this value to be assigned to the value that's been passed from the main class. And remember, we need to call this over here because we've got the same variables with the same name, and that would confuse the compiler as to which one we are referring to. Now, to override the toString method, I'm pretty much just doing the same thing, but I don't need to, instead of, I can explicitly call this one and let it just do the work by calling super, and then just adding that value. And I need to say toString and call the method explicitly like this. Okay, so that's pretty much it. Let's kind of do the same thing here, but for the child class. Just put a comment here for the child class. This is going to be of the child class A data type. And so that's calling the default constructor. And now over here, I've kind of given a different name, so child1. And the only difference now is I need to pass a third value of the float that we have kind of added to our child class. And last but not least, we want to print out the objects. Let's give this a nice run. So notice that these two were assigned through the Superclass constructor, and that's our third float value that was done here. So this part comes in to give us this value, to set these values. And then from the toString method, from the other object, we've passed the value test2, the value 2 integer, and 3.3 as the float. So we've got these values, and we were able to print a string representation because we've overridden the toString methods in both of the classes, the parent and the child. Okay, so I hope this helps you, and stay tuned for the next video because it's also going to help you understand how constructors can be chained and called. So stay tuned.